my presentation today is CI/CD on the Lakehouse, making data changes and repairs safe and easy. As many of you know, I am Alex Perset, developer advocate here at Dremio, basically constantly talking about the data lakehouse and all the cool things the data lakehouse can be, whether it be on blogs, podcasts, instructional videos. So we'll move on and get to our feature presentation. But on today's agenda, what I want to talk about today is, again, CI/CD and the Lakehouse. We're going to talk about, like, what is CI/CD? So when I say CI/CD, what does that mean? Okay, why does it matter? What is the big deal here? And then we're going to talk about how that relates to the topic that was a very big part of our today's keynote, which was the data as code paradigm. So we'll show some examples of like branching and isolation, version rollback, multi-table transactions, merging, publishing data, and then how to automate all that, or just possible strategies to automate that. Okay, so let's first talk about what CI/CD is. Okay, it stands for continuous integration and continuous deployment. So let's just talk about what those words mean and parse them out. So when I say integration, okay, because we're talking about the world of software development. This is like a typical software development practice. So when we talk about integration, we're talking about integrating new code into old code. But it's not just adding the new code, it's about doing it safely, doing it without bugs, doing it without hiccups. Okay, when we talk about deployment, it's about publishing that code so that application can be used to the world. But again, doing it safely, doing it without bugs. Okay, so we get what integration and deployment is, but what is continuous? So continuous is just the extra step of automating those steps. Okay, so for all the software developers out there, you might have experiences with tools like Git or Jenkins. You might be using like GitHub Actions where you push code up and then it triggers a series of unit tests and end-to-end tests. And if all those tests pass, then it gives it the go-ahead to then merge that code into the code base. And that allows you to be more productive and more safe with what you put out there. So why don't we try to adopt the same practices with our data? Okay, and why does this matter? Okay, because the quality of our code leads to the quality of our applications. And the better our applications are, the better the end user experience, the better business value, because you're going to have more users. Okay, same thing with our data quality. The better our data quality is, the better the insights that we get from that data, which again drives business value. So bottom line is quality equals business value. So it's a good investment to think about how can we improve quality. So in the paradigm, when we're talking about sort of the software development world, we think of this whole paradigm of we push the code, again, all those unit and end-to-end tests get automatically triggered. And then if all is successful, that code then gets merged into the code base. So that push, test, merge. How would that look like in the data world? Okay. Well, we'll think about it this way. We write the data. So we want to write the data. We want that data to be audited, but not published until that audit is successful. So write, audit, publish. And when we're thinking about Git-like semantics, that would mean sort of to branch and ingest that data on a branch, audit the data on that branch, and then merge that branch. Okay, so is that kind of, I think of that song Footy Tooty, so it's like whap, bam, lamb, I don't know, never mind. But, you know, we can think about like, or think of Emeril Lagasse, like bam, if I remember right, it's like his thing. Okay, branch, audit, merge. Okay, so we want to move to this paradigm. And again, why? Because the data as code paradigm is going to allow for isolation. So that's the whole idea, like branching and being able to do that ingestion work on a branch isolated from what your consumers are enjoying. Okay, so when Facebook is adding a new feature, okay, all those new features are being worked on a branch. I'm not accidentally seeing halfway written code when I'm, you know, checking my Facebook profile. Okay, same thing it should be with your data. Okay, a data analyst, a data scientist shouldn't be seeing half updated code while they're running their queries. Okay, so we want to isolate that work. We want version control. Okay, we make mistakes. Okay, nothing is worse than spending the weekend backfilling data. Okay, so in that case, we can avoid that if, hey, I can just roll back my mistakes and just say, hey, let me go back to a previous commit like I can do with my code. Okay, and then governance. Okay, nothing that happens when you're using Git is sometimes only certain people are allowed to push to certain branches. Only some people are allowed to authorize a merge. Okay, so being able to kind of have that visibility into who's doing what and be able to control who's doing what can have a lot of benefit. Okay, so all of these features, if we can apply that to our data, well, we'll make our lives a lot easier. Okay, so as I do this example, or I go through this example that we'll be discussing today, basically, let's kind of set the stage of sort of like the stack or our data stack that we're kind of imagining in the scenario. Okay, so we're imagining that we're landing our data, okay, because we have to have our data somewhere. So we're imagining some sort of like object storage as our data storage, whether it be like S3, Azure, Google Cloud, and that data has to be stored in a particular file type. So we'll imagine like Parquet, because we get the benefit of all those row groups and the metadata for those row groups to more efficiently query that data in that nice columnar binary format. Okay, we're going to need a data management tool. Okay, that's going to be the thing that kind of enables this whole data as code. In the same way Git allows us to manage our code, Dremio Arctic is going to allow us to manage our data in that same way. Particularly, it's going to allow us to manage the data that we have sitting in Iceberg tables. So Iceberg tables will be our table format. So basically, the tool that our engines and all our tools use to recognize groups of our files as tables. Okay. But at the end of the day, great that I have this data that's recognized as tables. I need an engine to query that data. So I'm going to be basically the way the queries you'll be seeing over the next few pages, they're based on syntax as you would use them in Dremio Sonar. Okay, but the cool thing about Dremio Sonar and other tools that are based on Arrow is that you can use Apache Arrow Flight as a one way to connect it to get extra fast connectivity. Okay, there's this video on YouTube where I compare, ODBC to Arrow Flight, and you can see it at different numbers of rows. And when you start getting to really high numbers of rows, you start seeing a real big difference in performance and being able to access that data quickly. So we're going to assume that you're connecting to your data using Apache Arrow Flight, which actually the next talk will be discussing, or Apache Arrow in general. So let's look forward to that next talk. And then again, we're going to assume that, hey, all your analysts are consuming that data, locally, maybe in a Jupyter notebook using their favorite data frame library like pandas or polars, or maybe they're basically taking that Arrow buffer and turning it into a DuckDB relation, or consuming a BI, turning it into a BI dashboard with Power BI or Tableau. They can consume it in all the tools that they want. Okay, but the idea is we want to manage that code so that way when they do their job, they don't have to worry about the quality of the data. They know that the code, the data that they have access to is the good stuff. Okay, so first thing, branching and isolation. So just to kind of set the stage, imagine that this is a company that handles like virtual assistants. So basically, we have a roster of virtual assistants who are willing to be a virtual assistant to somebody, and then we have a bunch of customers who hire these virtual assistants, and then we basically track sales, basically as virtual assistant for this customer. Okay, so then we have essentially three tables. We have our sales table, and then we have our two-dimension tables, which are our assistants and our customers. Okay. So in this, see here, the first couple of queries, what I'm doing is I'm creating a branch. So I'm going to say, you know what, I plan on ingesting some data. So I'm going to create a branch for ingesting that data. And then I'm going to make sure I switch my context over to that branch. So that way any query going forward is occurring on that branch. So you see that second line, the use branch line. Okay, then however you want to pull in your data, you can pull in your data. So in this case, what I'm doing is I'm just using a CTAS statement to pull in some data from another set of files. And then putting them over into a staging iceberg table. So I'll do, that's what that second statement is doing. And then what I'm going to do is I'm going to do an upsert on my data. I want to say, okay, here's my sales table. Here's my staging data. And I'm going to run a merge saying, okay, basically anytime the IDs match between these two, update the record. Anytime they don't match, insert the record, and all good. So now I've theoretically ingested the data, but I haven't had a chance to audit it yet. I haven't had a chance to run any kind of checks. But I don't have to worry about that. Why? Because all of this occurred on the branch. Okay, all my BI dashboards, everyone's notebooks are unaffected because their data is querying the data that is on the main branch, not the staging branch. So I don't have to worry about anyone giving me a call 5 minutes later being like, what happened? Okay, I can just kind of proceed forward. Okay, so now I'm going to want to go audit that data. Okay, so in this case, again, I'm switching over to my staging branch. Okay, and I'm doing a referential integrity check because basically, each of those sales is referring to a customer in the customers table and referring to a assistant in the assistants table. And I want to make sure that there's an actual record for each assistant and an actual record for each customer. So hopefully when I run this query, I should have the same count as the total number of records as the number of records that pass the referential integrity test. That's good, but if not, I have a problem. So I can run that test. So I run that test, and again, what if there is a problem? Or what if I pass that test, but then I make some other edits and I make a mistake? Well, I can just roll it back. And rolling it back is as easy as this. I just find the commit number that I would like to roll back to, and I just use this statement right here where I alter the branch, and I'm saying, hey, for this branch, make this branch point to this commit. And it's all like all those mistakes never happened, okay? Really with just one SQL statement. And it's not just for one table. Like if I made a mistake across 100 tables, that one statement would fix all 100 tables. Because Dremio Arctic does it at the catalog level. It's versioning the whole catalog. Okay, that's a big distinction over other solutions. There are other solutions that branch at the file level. there are solutions that branch at the table level, but then you have to go back and revert each table. Okay, files, there's a lot of other stuff going on, but when you have it at the catalog level, you just roll back and all your tables are back to where they were before. Okay, so this is see like the difference in sort of the benefit, the value of that different point of version control. Okay, but another cool thing that happens is that you can end up having multi-table transactions. Up till now, really, that was like a thing of the data warehouses. You do that whole begin transaction statement, and then you run a bunch of other SQL statements, and then you do an end transaction statement, and everything happens as one big atomic commit, and that's kind of nice. But how do you do that in a data lake? Well, here's how. Okay, so in this situation, again, I switched to my branch, and here I'm adding a new assistant, and I'm adding a new sale. Okay, normally, if I were just doing this on a data lake without branching, I would first add the assistant, or if I added the sale first, that might screw up the referential integrity, and I might end up having some bad queries before I finish all my updates. But because I do this all in the branch, I can wait till all my updates are done, and at the end, then I can just merge it back in, and all those updates have occur at the same time. So it's one big atomic update across all these tables that I've updated. Okay, so I can do multi-table transactions. Okay, and then I can then publish those changes through a merge transaction, just merge that branch, and now basically both branches should be identical, no difference. They should have the same kind of records because they now have all the same commits. Wonderful, okay? So again, I can branch, I can audit my data, and then I can merge. In the same way, we do that. Now, the missing piece is, hey, we've talked about integration, we've talked about deployment, but what about the continuous part, okay? Because the fun part is the automating of it, right? Because we don't have to do this manually every time. Well, there's a couple different options. And again, the options will continue to grow as this space expands, but basically all these queries are available in Dremio. So any tool that allows you to orchestrate Dremio, you can basically set up those pipelines to kind of handle that. That's one option. Okay, you could also create custom web services to handle this. So like in this example here, we're imagining a scenario where we have an ETL job. Okay, so imagine like you're using Spark or Flink to consume a data stream. And then what we do is, assuming that we're ingesting that data into some cloud like S3, okay, you have serverless functions that you can trigger when data hits your buckets. Okay, so basically we'll say, hey, a Lambda function gets triggered the minute that data gets ingested and sees those files in the bucket. And then that Lambda can then call a web service, in this case written in Python Flask, so that way we can use Python libraries. Okay, and that Python service, that Flask service, can then send all those queries to Dremio and run through all those checks. And then again, using like something connecting through either JDBC or connecting through Aeroflight, whatever your connection is of choice, but it can then take that return data, say, hey, did it pass this check? Did it pass this check? Did it pass this check? And once all the checks have been passed, send that final merge transaction. And then the cool thing is you can also then pull your business rules from somewhere else, because you can make a table in Dremio that has all your business rules, like saying, okay, hey, this table, like the cost of a service should never be less than $100, but never be more than $50,000 or something like that. You can take those business rules and use those in your audit because you have all that data accessible in Dremio. Okay, or you could use, but because you're using Python Flask, you could also bring that data down and then run it against other libraries like Great Expectations for doing a lot of different type of data quality checks and stuff like that. So you can kind of choose how you want to do it. So again, right now you have two choices. You can again use orchestration tools, whatever your favorite orchestration tool is, or you can create a custom service. But the idea is you can then automate all this process. And then, yeah, you now have CI/CD. You now have a process where you are continuously ingesting and you are continuously deploying your data with that whole branch audit merge process. Okay? And with that, that is the end of this presentation. My name is, again, Alex Merced. You can always email me at alex.merced@dremio.com. Please follow me on Twitter at amdatalakehouse. I like to post a lot of videos, and I have a lot of really cool videos, even on this topic, planned over the next few weeks. So you don't want to miss those.